Okay. For people joining this live stream, we are talking about some somewhat sophisticated features of the neural net framework in Wolfram Language. So there is a thing called netmap operator, which I already don't remember exactly what it does. So let's go look at its documentation. So this is part of the functional construction of neural nets. And mapped over a sequence of inputs to give a sequence of outputs. Okay. So there's a linear layer. I have to say that I've never been thrilled with this input arrow 2. I mean, it's always struck me as, what does that means? Why do you need the input arrow there?
Because it's a shape specification for the different ports. So typically, the ports can be named anything, but typically.
No, I understand, but why isn't it defaulting to the input port? If I just say summation layer of 2, anyway, that's a minor issue. Let's not deal with that right now. Okay, so let's just try to understand what this is doing. So threads across a batch of sequences of different lengths. So if I put okay, apply the sequence to a sequence of vectors. Okay, so this threads, okay, so if I were to put in another thing here, I don't quite understand. So if I were to put in a
that's already a batch. So
like this. Yeah, okay. So that takes the okay, I get it. Okay, so now what is the proposal?
So there are various limitations of this map operator, and we're relaxing many of them simultaneously because it's economical implementation-wise to do it. The core things are to have more than one input and output for the inner net.
Which is going to be horrifically complicated, isn't it?
I honestly don't think so.
Okay, well let's look at roughly what you're proposing.
Sure. So
okay.
Can you scroll up a little bit?
Yeah.
It's good to look at the examples, but I think it's also good to contextualize what these generalizations are conceptually. You can think of what this thing is doing, what mapping is in general, not just for neural networks, as a function that's kind of a little bit like a creature, like a little insect, and it's walking across the input array or input arrays.
What is it doing? Is it excreting things? It's like a spider that's producing a thread of silk? No, never mind.
Exactly. Yeah. So
okay.
The different inputs are different legs that it has, right? If there's only one input, which is the normal case with map, of course, then it's like hopping. It's got one leg, right?
I think the spider is losing it. But anyway, go ahead. So are you proposing, with respect to ordinary map, okay, obviously ordinary map has some just takes one argument forms. Are you proposing something where there's a multi-argument form there?
Essentially, yes. There is a connection to map thread, which is the multi-argument form. But it's more general than that, it turns out. Turns out that a language doesn't actually support the most general thing you could do.
Oh, well, let's forget the neural net case. What are we talking about here?
So I do connect it up, right? So connections to existing functions. You see that section there?
Yeah.
So more legs is like having more inputs. That's map thread.
Yeah.
There's no analogy for having more outputs. It's kind of a little bit
well, actually, there is with the new subset map.
Tell me about that. I didn't know about that.
I'll show you. Hopefully it's in here. So subset map See if you can guess what it is from its name and other things. Let me show you subset map.
Mm-hmm.
Oh, don't tell me it isn't in there. Maybe it's in the prototype build.
Yes, and there is a documentation page for that, at least in a futurized one.
Okay. All right, so let's see if subset map. Yes, subset map is in there. Okay, so let me show you subset map. So let's say then let's say range of 10, and then let's say 6, 8. Actually, I don't need the double brackets. I just need one level of brackets. Okay. Do you understand what it did?
Yeah.
Okay, so what this is doing is, this is a 2-argument, 2-output function. So for example, let's imagine you were doing a sorting network. This would immediately let you do a sorting network. You just give the elements, the interchanges to be made there. Make sense? I have to say, one thing I'm wondering, why do we not have a subset fold list, a subset fold?
Well, can I ask quickly?
I guess
that's 6, 8. That's say again.
Yeah, those are the positions.
So, but that's a span, is it not?
No, it doesn't intend to be a span. I could say it's not a span at all. That those are just part numbers.
Okay, you chose an ambiguous example. Then could you try 6, 9? Okay, yeah. So 7 and 8 remain unchanged.
Exactly. Right, and I could make this clearer by saying, if I put in there, let's say, actually, what will this do? Does that do it with the list? Yeah, that's right. That does the right thing.
Yeah, or if you just operate a map of F, that would also. So sure. It depends on that thing returning the same length of things.
Exactly. That is correct.
Yeah. Oh, that's nice.
Right.
Okay. Mm-hmm. Okay. It's not. It turns out that the generalizations we're talking about aren't really related to this. But
okay. All right. Fine. Okay. All right. Let's go on with these.
Sure. So adding more legs is like map thread. That's certainly true. But if those legs are output legs and it's excreting 2 separate arrays, then there's no way to do that with any function we have now. You can kind of fake it by doing a transpose.
Okay, just explain to me, independent of neural nets, what is the function you want? Just operating on lists and things.
It is a function that takes level specs for each of its separate arguments. That's to cut to the chase.
Well, what arguments does it have?
It's kind of like map thread in that it has a runtime defined number of arguments. So map thread will pass.
So map thread, let's remind ourselves what map thread does. So if we say A, B, C, D, right, map thread is going to do that. Right, it's going to be the transpose of that with F on those things. Okay, so now what is the thing you want?
So I want to point out that if you could you just copy that line down?
Yep.
If you replace the CD, that list, with just C on its own, single element,
it's going to fail.
It's going to fail. But in a sense,
it shouldn't fail because thread wouldn't fail.
Yes.
Thread would copy.
Thread would, yeah, it would effectively broadcast that C into C, C. But it's not just that. It's that if you had a matrix in the first argument, if
I mean, there's a certain argument that this should work and auto-duplicate that second argument, that second element.
Sure, I think that's the less compelling generalization because that's not general enough.
Okay.
My claim is that that the second argument of map thread takes this list of things, right?
Yep.
A list of these feeders, these sources. If they are things of different rank, it's very well defined what it means to walk over those things at different levels. So if I had a matrix, if the first guy was a matrix and the second guy was a vector,
Yeah, I get
I
it.
would want F to see duplicates of the vector elements as long as the dimension prefixes match.
Right. Well, so what you're saying is that you want a map thread where the third argument has more structure than just giving you a level spec, because the level spec would give you, so for example, if I say array A, let's say 222 here, that'll make that array. Now if I do a map thread of that onto that of that, so that's the first level map thread, right? Actually, let's do this to make it clearer what's going on. What am I doing? What did I do wrong here? Oh, because it's multi-argument. Eek.
Yeah, I think you want two separate arrays that are different ranks and things.
Okay, well, hold on a second. Let's first of all just do this. Okay, that's what that did. Okay, so now let me understand what the thing does at level 2. Okay. Okay, does that make sense to you? So at level 2, each thing is just getting I mean,
I don't find this easy to reason about, because you've got one array, but really, map thread, you want to think of those different arguments as different arrays that you zipping over.
All right. Okay. Fine. Let's do that. Okay. So then, what you're saying is, let's take this. Let's take the A array is this, and let's take the B array is the same thing.
But just 2-2, for example.
If you want to do that, okay. I was thinking, let's go even deeper. Okay. Okay, so now here you're saying A array, B array.
Mm-hmm.
Okay, and now if I
can't make head or tail of this, it feels too deep. And why have you got a framed and then mapping a frame? That seems very complicated.
Well, because I was putting the whole thing in an outer framed, because each framed here is going to show you what that's like a function. That outer framed is the function, and those are its two arguments.
Okay.
So here, okay, so this is now the next level down for each of those two. So this one, the arguments here. So what you're saying is what you would like this to do, right? So those are arguments which are the same there. They didn't dig all the way down on the A's. I'm sorry, they dug all the way down, well, almost all the way down on the A's, but they didn't dig all the way down on the B's. They've got 2 more levels to go on the B's.
Yes.
Okay. So now explain what you want. By the way, I'm sorry, this is a very minor point, but which I'd like to report. If Sushma, you see the icon is not there?
I see that, weird? Yeah.
Can you report that, please?
Yes, I will do that. And that's a prototype. Okay.
That's a prototype build.
Mm-hmm.
Okay. So, Tali, what are you proposing? You want something which can...
Can I go with an extremely simple example that you don't need to generate any A's or B's?
It's okay. All right. Okay. Hold on. Let me just save this somewhere. Hold on just a second.
Sure.
Okay, go ahead. What is it?
So if it's map thread of F, and then the A, you can use A and B, it might just help. But the A was going to be for the vector 1, 2, 3. And the B is going to be the matrix 1, 2, 3, 4, 5, 6. Actually, I apologize. 1, 2, 3, 4, 5, 6 has to be the same length. Oof, that's nasty.
Well, the good news is the silly bug, the off by one bug or whatever it was in the in selecting has now been fixed, so that was easier to type. Okay, right, I get it.
Okay. So what we would like to have is a deeper. If you put level 2 here, it wouldn't work. First of all, does MapThread does it limit it to level 2? I've never actually used that third argument of MapThread, or is it levels 1?
It can go to any level you want. I'm pretty sure this one, for example, could go to level 3. And I think it means at level 3.
That means at level 3, exactly.
Yeah.
Okay, so just to...
Yeah, go ahead.
So just to clarify, so if we did (2) in my example, it would fail.
It will fail. Yeah.
But what I would want is it just to say, okay...
Does it auto-replicate the first level, the first argument?
Auto-replicate to the depth the maximum depth I asked for. Well, in this case, the depth that I asked for, right?
Yeah. Yeah.
So that's feature number 1, is just this replication thing.
Okay.
But feature number 2 would be that you can actually, you can be very specific about how much replication you want. So for example, almost the opposite case of this is where we have 1, 2, 3 is the first input, and the second input is just 9, for example, just a scalar.
Yeah.
And I want to replicate that 9 up for that 1, 2, 3 there.
Look, basically what you want to do is you want to say, given a level spec here, you want everything. I mean, one thing to do would be to say, given that level spec, you want everything to either be at that level or to be replicated so that it can be at that level.
It's not as simple as that. And the reason is that, let's say that I had 999, right? That might actually be, I want that to be replicated even though it's already a vector of the right size. So I want to just...
So in other words, you want to treat it as a
constant
scalar.
Yeah. So there's a very meaningful way of doing that, which is just level 0. So I'm going to map the F over the first thing, the 1, 2, 3 at level 1. That's just what ordinary map does. And then the second argument, I want to be mapping over at level 0, which is another way of saying I'm not mapping over it at all. It's just being repeated. So it's kind of like...
So in a sense, what you want to do is you want to decorate the level specification by saying you have a target level. I mean, what you're going to do is something where you've got something like a list of levels for every element of the map thread, a list of target levels for every element of the map thread. Both what you want is a list of which contains both the whole thing has a certain level that it wants. Like it's going to be a level 2 map thread because that number there determines the shape of the output, right? So I'm going to claim that actually what it needs is a 4th argument. Okay, I'm going to claim this number defines the desired output shape. Get what I'm saying?
I'm not 100% sure, but I'm fairly sure that number is actually the maximum of all the levels that you specify. So in my scheme, in my scheme where I'm saying what level to map the F over each of the arguments, then whatever the max of those levels is, that is effectively the dimension of the output. Sort of definition.
No, but I'm saying that you can say that, but I'm saying a different way to slice this is to say that number defines the dimension of the output. Okay.
Okay.
So, and in what sense does it define the dimension of the output? The answer is the outermost list has always been removed because the outermost list is put innermost because that's the thing, because the F is threading over those things, right? So the outermost list is gone. So the question is then, what is the depth of the final result, right? So for example, this one here, %20, I claim is obviously of depth Oh, shoot. Well, I mean its list depth. I mean its dimensions. Right? So the depth of the length of the dimensions. So I claim here, he says, that the dimensions of this will be a thing of length 3. And I'm right. Okay? And this will be a thing of length. And if I were to say, for example, here, right, comma 4, that will be a thing of dimensions, where the dimensions, ugh, well, whatever. So it didn't make it there. So it couldn't do that because it wasn't deep enough. Right. But okay, so I'm claiming that the depth of the output tensor is determined by that n thing. And the only question then is, the only ambiguity is if you say I require it to be of that depth, then you have to replicate in certain cases. But the only thing you might want to do is to treat something as as a less of a tensor than you thought it was, more of a constant, and therefore you might want to replicate at you might want to start replication even though you could in principle burrow into the thing. Right?
Correct.
Okay, so I claim that we could change map thread to actually auto-replicate. Is that desirable? I don't know. Maybe it's better to just generate an error in this case. But so the point is that for every one of these things, you could be specific. That actually there is no ambiguity. Oh, is that? No, there is. For every one of the elements of this list, right, you have to say what its effective depth is. Right? And anything beyond that effective depth is a replication, needs to replicate. Get what I'm saying?
I think you're correct, but I think that's in the end going to be the opposite way that you'll want to specify it in practice. You're not going to want to specify what its effective depth is. You're going to want to specify at what level you wish to walk over it. So I'll give an example. If you want to treat something as constant, you don't want to have to calculate how deep it happens to be and then compensate against the depth you're mapping to figure out what the effective level is.
Right. So you want to say what the effective depth. Okay, so the parameters, if it was the fourth arg, gives the effective depth to assume for each element. Okay.
Yeah.
Right. So, okay. So what we're saying is that
can we do some examples? That would be very helpful.
Yes. But what I'm suggesting is that the way we think about it is map thread is okay. So roughly what this would be is, let's say, E1, E2, E3, whatever they are. Okay. Then this is D. D is the so D gives the list depth, so to speak, of the resulting tensor. Okay. And so by default, okay, and then this here gives, let's call them, we can just call them D1, D2, D3 here. Okay, so D1, DI are the effective list depths to assume for the EI, right? Okay, so to be specific here, what I'm saying is the effective list depth could be 0, in which case it's just pure replication, right? So for example, if I said map thread, so in your example here, this would be
I have a very specific claim that I'm going to make right away, and I might turn out to be wrong, which is D equals max of the DI, always, and has to be.
No, I don't think you're correct. Because I think you could have let me give you an example, okay? So here, Okay, wait a minute. Are the effective list steps to assume for the EI? Okay, so normally the default values here will be 1, 0, right? That's what those are. That's what they are on their face, so to speak. But if I were to say 0, 0 here, then the result that I would get would be the list. Actually, I don't want a 2 there. Well, maybe if I do get it, if I do put a 2, actually, I would 1 would be the max. No, 2 is that's right.
See,
So
you
this
can't
one,
have 0, 0 there because that means you're treating them as constant. But then there's no levels to map over anymore. Like you're treating them as scalars, but then you don't have any information about
why am I not just getting f of 1, 2, 3, comma 9? I mean, it's not very exciting, but why don't I get that? This level
where's
2.
The 2? The 2 doesn't make any sense anymore.
Yeah, the 2 doesn't make any sense. I agree.
Only one value for that argument makes sense, and it's the max of all the other things you've written, because the result that this thing produces, it got the shape of the result by mapping over at least one of those inputs to a certain depth. And it's specifically the deepest one that tells you the shape of the final output.
Right. Our people on the live stream are concluding the same thing that you're concluding.
Oh, really? And in the insect analogy, it's that the shape of its excreta comes from its walking, right? And the fastest it walks.
I don't think this insect is going to make it. I think. No, okay, so I agree with you. I think, and people on the live stream are making the same point, that I think the correct answer here is something where it looks like this, where for each of the E sub I, there's a depth specified.
Yeah, I think so.
And the alternative, the only question is, in the current situation where there's a single D, currently we're erroring out in the case where, that single D would be equivalent to the DDD case, presumably. Is that right?
I think it is. And what that requires, so specifically, there's a property we require for this thing to be well defined, which is that if you were to take the dimensions of the EIs in sequence, and then for each one, take the DI first of those dimensions, all of those prefixes have to match. So the first D1 dimensions of E1 have to match the first D2 dimensions of E2, etc.
Yeah, I think I agree. And then everything replicates beyond that. So it doesn't matter. So the dimensions, well, I'm not sure. Let's see. We have various comments on the live stream here. Okay, so we have, let's just take a look here. A very complicated case here, sent through by, what is this? This is, the claim is that would be what was going on. But this is now, so do we believe this? Oh, that's an interesting suggestion. The suggestion is an option broadcast arrow automatic. I think broadcast is it's a little bit of a complex analogy, but that's.
I think that there's a very interesting meeting we should and need to have about broadcasting at some point. I even have an alternative name, which is replicate, which I think is like more direct and evocative, even though everyone calls it broadcasting in other languages.
What do you mean?
But yes, there is a story about there's a whole missing piece for a lot of what's going on to do with broadcasting.
And what do you mean? What do you mean?
I mean, it's very difficult, nigh impossible to do broadcasting on arrays in our language.
What do you mean? I don't even know what that means.
So broadcasting is when you introduce dimensions in the middle of an array, and you will copy the subtensors up to fill in that dimension that you've introduced.
Right.
Other
So
frameworks,
we've done a bunch
yeah.
of things with flatten and array flatten and so on that relate to that.
Okay. What are you referring to?
Well, I mean, let's not go through this right now. I mean, for example, array flatten has a whole bunch of capabilities, and also the multiple arguments of flatten do a bunch of things like this. Perhaps there's some missing documentation related to this because I've not heard the term broadcast referring to that particular operation on arrays. So that's Sushma. That's something for you to note down, and maybe we can pick this up in some ILD meeting and write tally, and we'll talk about whatever this is.
Okay.
Yeah. That's what I'd like to do, and maybe not. It's a bit of a rabbit hole, so let's. I think suggest not.
This is not for now, right?
Yeah.
Okay, so somebody is commenting that thread of f of a b. Okay, what is this identity? Really?
If f doesn't evaluate, then that can sometimes be true.
Yeah, I don't think, but that's not generally true.
It's not generally true.
Okay, Sandra on a live stream is saying for the dimensions, the following should hold, he says. Let's see his claim here.
Flatten dimensions. The two part is confusing me.
Well, that's a flatten at level. That's in fact something related to what you were just talking about. That's a flatten at level 2.
Okay, but the dimensions of all those things, that's already a matrix. So why does flattening at level 2 do anything to it?
I think we'd have to try this. Okay, but in any case, let's zoom out for a minute. So far as we can tell, okay, so the claim here is that we can simply specify the D1, the D sub I here, and the only question that we don't know the answer to is this identity here. Is this identity correct, or is it something more complicated?
No. I'm very confident that is correct.
That this is correct?
Yep.
Okay, walk me through what the D sub I mean again. What is the description of the D sub I?
The D sub I mean, I'm going to just revert to the language that I use internally in my brain to think about this, which is you're mapping a function across these different arguments simultaneously, but at different levels for the different arguments. Those D sub I are the different levels. It's how deep you go into each of those E's to accomplish the mapping. And
right. But when you have to go deeper, I mean, the max of the D sub I,
anything shorter than that gets
I, right? Ultimately, the tensor you produce is of size max of the D sub I.
Exactly. So it is the deepest thing, the deepest D. So specifically, there's a kind of.
So wait a minute. Yeah. Does the mapping to level DI in EI replicating EI if necessary to
it's actually replicating the other EIs. So if one of the E's is deeper than the others and you're mapping over it deeper than the others.
Okay. Replicating any EI. No, that's not right, because this DI specifies replicating the EI if the max, okay, so this produces a tensor of depth max of the DIs. Right?
Correct. At least. The F could return
the F could do whatever crazy thing it does, right?
Sure, yeah.
Okay, so it does the mapping to level D sub I. Okay. replicating whatever it finds at that level if it needs to in order to get a final tensor of depth max di. That's horribly said, but I think that's a correct statement. Right?
Yes.
So there's two cases, because it could be the case that the d sub I is shallower than the actual element e sub I, in which case what it's doing is it's treating the deeper depths of e sub I as a scalar, effectively.
Mm-hmm.
Right? Or
yep.
the d sub I could be defining, how deep you go in that e sub I.
Yes, and here's a crucial point that I was worried you were getting wrong, which is that di cannot be deeper, cannot be higher than the depth of the corresponding e sub I. That's not where the replication happens.
No, I agree.
Mm.
It must be the case that for each I, d sub I is less than or equal to e sub I. Right?
The depth of e sub I.
Oh, the depth of e sub I, the list depth of e sub I.
Array depth, I think, is the actual thing.
Yeah, that's right.
And so maybe a better way to talk about the broadcasting is something like all EI for which DI is less than the max get replicated to effectively be of the max depth.
No, that's not right. That's not right. No, it's not right. No, it's not right, because all EI, the whole point is you're assuming a fake depth DI for the EI, right? The depth DI could be not the full depth of the EI, right? You're assuming that it could be the case that the lower layers. Okay, consider the following. Okay, we have something which has the form, 1, 2, 5, 6. Okay, we can either treat that as something which is to be mapped over at level 1 or at level 2, right? So the d sub I says, so in this one, if the d sub I is 1, then what will end up happening is it will treat 1, 2 as a lump, as a scalar lump, right?
Agreed.
If the d sub I is 2, then it will dig down into those things.
No, I agree. Yeah, I totally agree.
Assuming that the total max DI is big enough that digging is what it is calling for.
Yes. No, I'm not talking about that. You can't really. My point is not really about one EI in isolation. It's that if you had a second thing which was like 9, that was E1, and E2 is like 9.
Okay.
Right. And therefore necessarily had a corresponding depth of 0. That's the only depth you're allowed to use for 9. Then,
okay, so your point is that the DI in that case is kind of redundant for the 9, for the element that is 9.
No, it's not my point.
But that's true, in fact, because the only value the DI could have there is 0.
Yes, that is true. But the point I was trying to make is that the fact that the 9 gets replicated, what we've got to communicate in the usage message of this putative extension of MapThread is how exactly that 9 gets replicated and under what conditions it gets replicated. And what I'm trying to find is the right language for, the depth is 0. That depth 0 is less than the depth of the other arguments, which might be 1 or 2 or something. And that tells you how many ranks get replicated of that 9.
Sure. So in this case, if it was the 9 compared to this, and it was going to depth 2, then you'd be doing, then effectively the 9. If this was a depth 2 thing, then what effectively would happen is that 9 would effectively be this.
Yeah, exactly.
Right. So I mean, in general, the amount of replication is basically, is array of the thing, and then a list of length,
some dimensions. Yeah,
Well, of length max of di.
I think it's max di minus d. It's max di minus particular di, right?
No, I don't think so. Oh, yeah. For this case, I'm sorry. Yes, you're right. I was talking about this case where it's a scalar. Yes, it's the list of length max di minus probably +1. I think minus di.
Yeah.
1.
And that's effectively that's the deficit of rank that you're filling in. That's really what it is.
Yes, that's right. That's all it is. Yes,
that's all it is.
Right. Fills in whatever rank a particular element doesn't have, so to speak.
Exactly. Okay, I can't resist. I have to tell you what at least part of the story for what my proposal is for broadcasting more generally in the language, and that is it's a wrapper called replicated. You'll see why it makes sense. It's a wrapper called replicated.
Yes.
And what it does is replicated of arg, the thing that you want to replicate, comma, and then how much rank to add. So like that deficit too. And all it means is if you're doing, like, let's say you're doing total, or let's say you're adding a vector to a matrix, as I'm sure you've know from many decades with the language, if that's the wrong way around, it's kind of frustrating how to do it.
Tally. That's clever. Right. So what you can say, if you say the list 6, 7 plus replicated 5, 1.
That case works already with listability, right?
Well, that particular one does, yes. But there are plenty of cases like that don't work.
Right. So like maybe a matrix with some 2 vectors in it, and the matrix has got 3 of those 2 vectors in it.
Okay.
And then you want to add another 2 vector. Listability, it does do replication, but from the wrong side.
But the problem with this is that, I mean, what really you'd want to do here is just say replicated of 6, 7 and have that do have the auto listability, so to speak, figure out what the rank has to be.
And it can. That can be perfect. And the rules for it are very well defined, which is the thing that replicated appears as an argument of, in this case, plus. It has a bunch of other arguments. They have dimensions. Just look at them and see what the replicated argument is missing and fill it in. Fill in those dimensions by replication.
Yeah, I understand. This is a good idea. This is a very interesting idea. Surprising we didn't think of this in the last 30 years. Well done. Okay.
We should have a proper treatment of it another time, perhaps.
Yes. Okay. For the ILD agenda. Okay. Now, Seth on the live stream is talking about what happens in a particular map thread. Let me just copy that out. So this map thread. What does happen in that map thread? Tally?
I don't know. If you use the default,
so
the default third argument is 1. That'll always fail.
Right, but if the default third argument was 0, it would treat these as scalars.
No, the default can't. Yeah, you can't have a max of 0. That's actually just compose. That's just like what's applied. Actually, is what it is.
Yes, it's applied. Right.
Yeah.
Okay, but so the claim is this can never work. And do we ever want this to mean anything? Yes, there's a possible thing we could have this mean. The thing we could have this mean, yes, there is a sense. No, this is incorrect. Okay, the following thing should work. Okay? I claim this should work. Okay? And what that should do is it should return f of 1,45, comma, f of 2,45, etc. Right? Now notice that there's an identity here because this is the same as saying, oops, that's the same as if we wanted to, if I'm going replication crazy, I could say in here replicated 4,5.
Yes, it is.
level 1.
Yeah, that's true.
Okay. All right. Well, I think we've got a winner here in terms of map thread, and I really love this replicated idea. I really love that idea. I mean, that will solve a whole bunch of weird problems with listability. It's kind of it's a sort of a it's a way of controlling listability, an interesting way of controlling listability. Okay, all right. So let's go back and look at the original neural net case. And what are we going to do with map thread? Are we able to put these new arguments in? Do you think that's possible?
I mean, it's C, so
that
it's
seems
going
really
to be involved.
hard to achieve before the free state.
Yeah, I don't think that's realistic. One question is, does this suggest that we should have a net map thread operator that behaves quite differently to net map operator? I was imagining we would just extend net map operator.
Net map thread. I don't think this is a net map operator thing. I mean, this seems much more like a map thread, because this type of control, this type of multi-legged, not wishing to spider this up too much, but this sort of multi-legged behavior is really not a map kind of thing. If that's what this operator is doing. Yeah. Is that what this operator is doing?
It is, yeah. I mean, there's some little details that are quite unique to neural networks. Like, for example, we have to look at the inner net. So just, you recall that mean absolute loss layer, if you just copy that constructor out and run it.
This constructor here.
Yes. You'll see that it's a 2-argumented, it's got so it's got two inputs and 1 output. You have a broken old build. Just use 11.3 for now. It's no different there.
Okay. All right. Okay.
Okay. Yeah.
So now what?
So just expand that so you can see all both the inputs and the outputs at the same time. So input and output, it's got an input, a target, and an output. The output is loss.
Okay.
That you have to only, you want to map over the input and the target simultaneously. So that's a sort of map thread type situation.
Yes.
But we have this unique property that the inputs and outputs are actually named, right? They effectively always associations.
Yes.
That's a different extension to map thread that I think is quite reasonable, which is to make them work on associations, not just lists. But,
yes.
But we can.
Right. So that's effectively, that particular thing is the subcase of associations, right? Which I don't think map thread works on at all right now.
It doesn't, and it's always frustrated me.
Well, we should probably fix it. I mean, so what you're saying is there's a K1 E1 here, K2 E2, right? That doesn't seem particularly problematic.
Yeah, and all that would do is it would pass those same sub-associations to F, I imagine, right? K1 goes to some part of E1.
Yes, exactly. Wait, hold on. Actually, hold on. This isn't the right picture. Which picture are you talking about? Are you talking about this picture here?
No, that's the right picture. No. What you had before is perfectly good.
Okay. But then what's passed to F is something of the form. So let's imagine these E1s. Are you imagining that E1 is the list 1, 2, for example? And E2 is the list 3, 4, for instance. Okay, sure. Then what's passed to F, I don't think is what you think it is. I think oh yes, it is. I'm sorry. So then what's passed to F is F of K1 arrow 1, K2 arrow 3, right?
That seems very reasonable to me.
But then what this is going to return... Okay, so hold on a second. So this is effectively a transpose where it's taking that inner list and it's extracting the inner list as the outermost wrapper here. And this is going to end up with that arrow 2, 4, correct?
Sure.
Yeah, I think it's perfectly reasonable for that to work. I mean, is it the case if I were to take, yeah, I mean, because this is analogous to saying F mapped over this, right? Does that. So I believe this is kind of an analogous thing.
Well, try a thread of F of an association. That would, I think, make it a slam dunk argument. I don't know if that works, but it could. No, that doesn't do anything.
That could work, I think.
Yeah, I mean, in theory.
Well, let's just think what that would do. So what the thread would do in that case is the same thing that we're proposing the map thread is doing here. Right? I mean, in other words,
I don't know.
What's that?
I don't know.
Yeah,
Take
sure.
away the keys and a few.
No, I know so. But if I do this, if I just say 1, 2, 3, 4, then that will thread like that, right?
Mm-hmm.
So the correct thing for this to do is exactly what we're proposing map thread to do, where the correct thing then is on the association is for this thing to come out as essentially exactly this.
You know what's a bit different about it is that there's a missing list. So that thread works, that final thread with the 1, 2, 3, 4, F of 1, 2, 3, 4. But
actually, this is the wrong case. This is the wrong case to look at. This is the wrong case. The correct case for this thread, the correct thing for this to do, if you thread this, would be to give K1 arrow what is the right thing? It's that. Okay, let's look at this case here. So if I say humph, what is the right thing? So the thread of this
the thing is that thread fundamentally wants to match different arguments of the F. But with the association, you've only got one argument, which is the association.
Yeah, so in fact, this is the wrong analogy. This is the wrong analogy. What we should be looking at is, this is what we should be looking at, is K goes to 1, K2 goes to 3, let's say, and then a second argument here, which is this thing goes to 2, that thing goes to 4. Right? That's the correct analogy.
That is, yes.
And then, in fact, that thread, which undoubtedly doesn't work right now, should be K1. Yes, this is correct. K1 goes to F of 1, 2. K2 goes to F of 3, 4.
3, 4. Yes, that's true.
Okay.
The truth, but I actually agree, and I think we should fix that. That doesn't honestly have much to do with the map thread, though.
Well, but I think it's the same issue. I mean, it's both of these things could be fixed.
Yeah, it's in the same family of association-related threading issues. Yeah.
Yes. Okay, so Sushma, please, an ILD meeting, covering.
Yeah, all of Tally's.
Well, all of Tally's ideas, but no, that would take. Just this one for the associations. Then this is a simpler thing. Okay, generalizing map thread, putting in these association things, and then we'll address the replicated idea.
Oh, so the association one should be sooner than later?
Well, it's not going to make it for 12.
Yeah.
I mean, that would be, look, put all three of them together, but replicate the third element in that list, so to speak. Okay, meanwhile, on our live stream, various questions and comments here. There's a question about the NVIDIA RTX 2000 series. Anybody here know anything about that?
Yes.
And?
So basically, 11.3 doesn't work for it because it's using an older version of CUDA. And the version of CUDA that supports this new GPU was only released about 10 days ago. So
okay. Will version 12 support it?
Yep.
Yes. Amazing. Even though it was only released 10 days ago?
Yeah, we're rebuilding MXNet like in the next few days with that.
Okay. Is that part of did somebody else add that to MXNet, or did we have to do that? What happened?
It seems like MXNet builds correctly against CUDA 10, so there was nothing for us to do.
Okay. Good. Okay, so that's the answer to that question. Is it going to have some spectacular? I'm not following all the serial numbers of all these different devices. So, is that something particularly spectacular?
The nice thing is that even consumer cards are getting tensor cores. So we're hoping to leverage tensor cores for 12. Previously, like only the very expensive professional GPUs had them.
I see. Oh, that is exciting. Does that mean my next generation laptop is going to? I have no idea what GPU like my laptop has in it. What is in Macs these days?
They're all AMDs.
So does that mean nothing works? In terms of GPU extensions, does MXNet support the? Yeah, go ahead.
Yeah, sorry. So basically, MXNet doesn't support OpenCL or whatever the thing is for AMD. AMD is working on a fork for MXNet, so there's plans probably for next year to have
about support. Time too. They should hop on it. Otherwise, they're going to get left behind. Okay. Various comments on our live stream. Somebody is commenting that Carl Lang is commenting. Can't you use threading layer of netmap operator for that? But I'm not sure what the that is anymore.
I mean, that's a kind of bit of a Frankensteinian monster, it feels like. Threading layer, yeah. Threading layer, the argument of threading layer is a scalar function, fundamentally. I don't think it makes sense to give it a net.
Are you sure?
Yeah, and look, the other thing I would say is that net function will introduce a different way of creating nets that will make some of these things somewhat obsolete. So like you wouldn't even use net map operator, you just use the map thread directly, right?
By the way, so, SWSH on our live stream is claiming this identity.
That is correct, yes.
Okay. Okay, so back to netmap operator or netmap thread operator.
Yeah. Can we go through the proposed design? Because I think
yes.
I think it's you'll just agree, and then we can document it.
Okay.
So the difference with the map thread that I really like that, by the way. I hadn't thought of extending map thread. I thought this would require a new function, but that is obviously the right way to do it, to extend map thread.
Okay. So, but back to what you are proposing here. You are proposing changes to the net map operator, and
we could make a new operator, net map thread operator.
Yeah, but certainly, what changes are you proposing for net map operator?
The second argument that takes the levels, and they're per input levels, just like what we've been discussing.
Yes.
The only difference is they are identified with particular string inputs, so particular named input ports rather than positional input ports.
I see, like this.
Yes.
Can they be an association, or is there no uniqueness of the left-hand sides?
It could be an association, sure.
Okay, fine. But so you're proposing here that this seems harmless, honestly. I don't think this is ultimately the way that this stuff will be done, because I think, once we have net function and more of this kind of higher level representation, I suspect we'll be able to do that instead. But this seems like a perfectly reasonable way to annotate net map operator.
Exactly.
Which doesn't have a second argument right now.
Exactly, yeah.
Okay, and the behavior of these things will be the same as the d sub i's of map thread that we've been proposing, correct?
They will be exactly the same.
Okay, seems okay.
And a single integer just means use that integer for all the different inputs.
Fine with me. Oh, wait a minute. Is that the same behavior as the map thread proposal?
Yes, it is.
Okay, all right, fine with me.
Okay.
Single string means that one is 1 and the rest are zeros. All right, it's harmless, I think. Okay?
Okay, cool. So fold operator is the trickier case.
Lovely. Okay.
It's tricky because the main generalization is, again, now that we are going to support multiple inputs, not just sort of hard-coded one input and one state, you need to say how the states connect to each other. So do you want a quick refresher on that fold operator?
Well, I thought I understood it. I mean, as a fold, but when you say the states connect, that's in order to feed in a fold, you obviously have to feed the thing on to the next stage in the fold. Is that what you're talking about?
Yes. So the net, that inner net will produce two outputs or more. One of them you save to be just part of the final list. The other is the state that is passed forward to one of the inputs of the next.
But that's fold pair list. I mean, isn't that fold pair?
Yep. No, we know this. We just didn't call it net fold pair operator because it was sort of needlessly complicated.
What do you mean it's needlessly complicated? I mean, and fold pair is a fairly complicated idea, but if this is in fact doing a fold pair, and now that's coming out. So anyway, what are you proposing here? You're proposing this is, okay, that's the fold operator, but it's actually a fold pair operator. And
the complexity, the extra feature we're adding is to say which outputs get fed back into which inputs.
I get it. I mean, in principle, fold pair could have a thing like this as well. Right?
How many arguments does it have now? I seem to remember it being pretty rich. But I might be wrong.
No? Oh, well, it has quite a few. Yeah, it has. Okay, so what are those arguments there? So the successive x sub I obtained by applying f to pairs of the form y sub I, a sub I. Right, where at each step it emits an x and returns the y sub I that will be fed on.
Mm-hmm.
Okay, so what you're doing here is you're saying from which port the thing that will be fed on comes. Is that right? So you're effectively saying, instead of where here, f has to return. Actually, it's sort of an interesting generalization, because for both fold pair list and for subset map, we're dealing with, which by the way reminds me, Sushma, can we make sure that fold pair list refers to subset map and vice versa?
Mm-hmm. Okay.
So, okay, hold on. Let's so what I'm saying is, right now, which thing comes out as the next y sub I? So f, you get what I'm saying? F is returning x sub I, y sub I, right? And the emitted thing is being extracted as the first element of that, and the fed on thing is the second element. But that's pretty arbitrary. In principle, there could be another argument or some structure, which is what you're proposing here, that determines which of the things that f returns, which thing is which thing is returned as value and which thing is fed on.
Yes, and it's really multiple things could be fed back. So that pair could become a general tuple. That's actually, LSTMs do that. LSTMs have two separate states that are maintained separately. Now, in the language, that doesn't much matter because you can always keep the separate states as a,
I understand, as a list.
But like in the world of these frameworks, we don't have that notion of like compound objects. It's just tensors. And I wish we did have the notion of those compound objects, but it's too late to add that.
Perhaps we should consider that. That's a separate discussion. Right. Okay. So for this purpose here, what are we saying? So what you're proposing is a thing that specifies what can be fed on. Which one of these is I'm sorry, which one is the But what you're saying is the F returns this, and then the question is where do those which pieces get returned and where do they get plugged in? That's what you're basically saying here.
Yeah. I think we're just talking about which get plugged in. I don't think. Let me double check. Could you bring up netfold operator? Sorry, just so everyone can see.
Yeah.
Embarrassing to admit, but I need to be. Yes, there's only one output in that core there.
To compute SI effectively using net of input arrow SI, state arrow that.
Mm-hmm.
Okay, so what are you proposing here?
So what I'm proposing is that list of rules tells you which output gets fed back to which input in the next step.
What do you mean by which input? I mean, one means what? Because here I'm seeing the input is an association.
Yes. So
what does one mean? Does one mean an association with key element with key one?
So that is mapping. So that's an awkwardness. Maybe let's just strike out option one as clearly stupid because it's confusing. It's joining the mapping with the state recurrences.
All right. Okay. Fine.
Idea.
Okay. Okay. So what does this mean here?
That's saying expect the net to have an output called state and feed that output called state back into the input called state. A different input.
Okay. Then what does this mean?
That was meant to be the level at which you're going to map over, because not only are you doing some feeding back, but you're also separately mapping over an input sequence. Remember the A's. If you go back to fold pair list, it was the list, all the A's that were coming from the input list.
Yes.
So in theory, you can map at level 2. So you can map the pixels of an image, for example, and you maintaining state from...
Okay, but so that means a completely different thing. I mean, the state arrow state thing is a completely different type of thing. That's kind of the knitting together of the things inside the fold. And this has to do with how you iterate, how the fold... I don't even understand how that can work, because fold is a very threaded linear thing. It doesn't... fold doesn't get to go over a two-dimensional array.
It quite easily can, though.
How? What order?
The same order as map does. So in an image, for example, top to bottom, left to right.
So as a courtesy, then, what you're doing is you're mapping you're first flattening and then folding. Is that correct?
I don't think it is correct. No. So the states can be passed on different levels. That's actually an extension that I mentioned at the bottom of this section.
Yeah, so that's the same thing as the map thread thing of the as-if scalar at a certain level.
I think so. I'm not sure. But can you sorry, I should have put an image of this in the notebook. Could you just Google for grid LSTM? You'll see some nice pictures, I'm sure.
All right. Okay. I have to get going soon, unfortunately. And we have a request. Okay, I really have to go in a moment, but let's.
You know what? I realize now, and maybe you'll forgive me because I think at least the first section we nailed. I realize now that this netfold operator proposal needs a little bit of work. It's also the one I haven't implemented yet, so it's. I would have tightened up this definition if
in the slightest bit. I don't know what the heck this picture is of.
So the basic idea is that
picture is utterly obscure.
It is somewhat, because they're also 2 separate states for each cell. But the basic idea is that as you're mapping, you're obtaining a state from the pixel to your left and from the pixel above you.
Yes.
Right.
Well, that's otherwise known as a block map. Right. That's what block map does.
No, there's no dependency between. There's a running state that connects all the tiles, all the little applications of F.
I see. So this is essentially a block fold.
Yeah, it's a two-dimensional. Exactly, it's a two-dimensional fold. And I think it's
fold because it has to depend on certain previous things. I think.
Yes, it does have to depend on the thing above it and the thing to the left.
What is fun about all of this is that all of this list manipulation. I thought we'd figured out every conceivable, iteration, but it is interesting that the neural net world introduces yet more kind of tensorology. Okay, so that's for the next time. Okay, just a quick thing for our live stream folk. They really want to see net function. What can we show them about net function?
Net function sadly will not ship for 12. It is 12.1 now, but a very high priority. But I will mention one thing.
Just show one thing on the screen, just for people to see something about what net function is.
Sure, I can share.
Okay, all right, super quick here.
Go ahead. Let me make sure that I have my notebook that I want to share on screen. Okay, so so the first place that net function-like functionality will show up, and I actually thought we were going to ship this for 12 because it's quite limited in scope, but will be the way that you define losses. So when you have a net, there's the object that you want to use at the end of training, right? The thing that sort of does the task at hand. But that's often quite different from how the net is trained. And we have very limited amount of functionality currently to elaborate that evaluation net so that it's able to be trained. And there's a certain amount of automatic magic that happens with the still picture that you'll remember. Mm-hmm. But we want to overhaul this quite considerably so that you can much more flexibly kind of construct the training environment for the net where it's sort of going to be taught. And this, what you see here is a sort of a prototype of what that'll look like. And what it'll look like is you've got access to the training data. So these are keys from the training data.
Yeah, I get it.
And you've also got access to the net. And then you just write what the thing is that you're trying to minimize. And this will be symbolically evaluated. It won't actually see training data initially. We'll evaluate this to construct a bigger net that will be the training environment. But then what you get back at the end of training is just the net.
I don't see the word net function anywhere here.
Well, exactly. It's not here because this is a limited enough slice of functionality that it looks like ordinary function application. And we can...
Okay. But ultimately, net function is going to have to use the compiler and everything. Yes? Is that true?
I think the compiler stuff will more be used for custom layers than for net function.
Okay. Well, I haven't yet understood net function then. Okay, so...
Yeah. There's nice things this unlocks, like GAN training and all kinds of things.
How does it unlock? I'm sorry, how does it unlock GAN training?
The story is still a little complicated there, and I'm not sure I have 100% figured it out, but that one of the things that will make it easy to do is you'll define several pieces of your net, and then you can kind of assemble them in the loss function. So there's a generator and a discriminator.
That's really interesting. That's cool. Yeah, that's really cool. That is very interesting. That I had not understood how the GAN mechanism was going to fit in.
This comes with, so one of the reasons that net function becomes is actually such a big project is that it requires us to port a lot of the sort of like innovations, I guess you could call them, from the neural net side of things into the language itself. So a good example would be what we're doing with MapThread. We would need that to be there so that you can express those kinds of nets as pure Mathematica code.
So by the way, yeah.
And there's quite a number of those things we will still need to, of course, I will present what those designs look like. I'm not going to assume that, we can just put things in directly. We will need to find a way to map that functionality over. And that's one of the reasons it's tough.
Fair enough. Carl Lang on our live stream is complaining about having to do too much work to create loss functions. It will be interesting. I encourage you to send us some examples of loss functions and what you've had to do, because then we can make sure that in the future version, all that stuff is unscrambled. All right, I need to go. Great. All right, so there's some documentation work and there's one more iteration here with this net fold thing that are going to be needed, right?
Correct.
Those who are interested in live streaming, my gosh, we're going to be doing another live stream probably in about 45 minutes, 30 minutes about web execute functionality, then something about unsupervised learning, and then something about geometric computing. And then, see, this is what happens near the end of a version. This is just a whole vast long list, and then one about natural language processing after that. So exciting stuff. Thanks all. See you later.
Thanks. Bye.
Bye.